The objective of image compression is to reduce irrelevance and redundancy of the image data in order to be able to store or transmit data in an efficient form. Lossy compression methods, especially when used at low bit rates, introduce compression artifacts. Lossy methods are especially suitable for natural images, such as photographs in applications where minor, sometimes imperceptible, loss of fidelity is acceptable to achieve a substantial reduction in bitrate. Lossy compression Lossy compression that produces negligible differences may be called visually lossless. Methods for lossless image compression are run-length encoding, used in default method in PCX and as one of possible in BMP, TGA, and TIFF. The second, area image compression. The third, DPCN and predictive coding. Fourth, entropy encoding. And fifth, adaptive dictionary algorithms such as LZW, used in GIF and TIFF. And then deflation, used in PNG, MNG, and TIFF. And the last one is chain codes. Methods for lossy compression is reducing the color space to the most common colors in the image. The selected colors are specified in the color palette in the header of the compressed image. Each pixel just references the index of a color in the color palette. This method can be combined with dithering to avoid posterization. And second, chroma subsampling. This takes advantage of the fact that the human eye perceives spatial changes of brightness more sharply than those of color by averaging or dropping some of the chrominance information in the image. And the third, transform coding. This is the most commonly used method. In particular, a Fourier-related transform such as the discrete Gaussian transform, or DCT, is widely used. The best image quality at a given bitrate or compression rate is the main goal of image compression. However, there are other important properties of image compression schemes. Scalability generally refers to a quality reduction achieved by manipulation of bit stream or file without decompression and recompression. Other names for scalability are progressive coding or embedded bit streams. Despite its contrary nature, scalability also may be found in lossless codecs, usually in form of coarse-to-fine pixel scans. Scalability is especially useful for previewing images while downloading them, example in web browser, or for providing variable quality access to example database. There are several types of scalability. The number one is quality progressive. The first one, quality progressive or layer progressive. The bitstream successfully refines the reconstructed image. The second, resolution progressive. First encode a lower image resolution, then encode the difference to higher resolutions. And the last one is component progressive. First encode gray, then color. Region of interest coding. Certain parts of the image are encoded with higher quality than others. This may be combined with scalability. Encode this part first, others later. Meta information. Compressed data may contain information about the image which may be used to categorize, search, or browse images. Such information may include color and texture statistics, small preview images, and author or copyright information. And processing power. Compression algorithms require different amounts of processing power to encode and decode. Some high compression algorithms require high processing power. The quality of a compression method often is measured by the peak signal-to-noise ratio. It measures the amount of noise introduced through lossy compression of the image. However, the subjective judgment of the viewer also is regarded as an important measure, perhaps being the most important measure.